Hey, welcome back everyone. Today we are going to discuss a balanced binary tree problem. So we are given a binary tree and we want to determine if this if its height is balanced or not. Okay. So how can we determine if its height is balanced? We can check like if from a particular node, if the left and right left and right subtrees, if their height differ by um, more than one, then it is not a balanced binary tree. Otherwise it's a binary tree if at any stage the height difference between the left and the right subtree of any of the subtrees satisfies this criteria. Okay. Let's see how we can go about it. So first of all, we want to calculate the height of the tree at any given point in time. So for that, let's say we can create a new method, get height, and to this method we will pass a node. Let's call it root, and it would return the height of the tree. Okay, we get the height of the tree. So we will get the height of the tree. Okay, so corner case, if root is null, in that case we would return 0. Okay, and otherwise we would return 1 plus math dot max of get height of the left subtree and get height of the right subtree. Okay, so this would give us the height. So here if inside a balanced tree, if we have the root node as null, then it is already balanced. Okay, otherwise what we can do is we should check if the left and the right subtree are also balanced. So is left balanced, okay, and similarly is right balanced, okay. And if the height of the left and the right subtree, if the difference between them, so let's find the difference. If the height difference, get height of the left subtree and get height of the right subtree, okay, and we would see if is left balanced and is right balanced, and the height diff is less than equal to 1. In that case we would return true. Otherwise, if it does not satisfy, we would return false. Okay, so this seems to be the case. So let's try to run this. Okay, oh, we are trying to find here. Okay, so we are trying to find the difference here, and height diff is left balanced. Okay, it should be capital. Okay, we are able to find a solution. Let's try to submit it. Okay, so there is a problem, like this is taking a very huge amount of time, which is 94 milliseconds. So the question is, can we make it faster? And the answer is definitely yes, we can make it faster, but yeah, okay, let's try to make it a little faster. So we can use dynamic programming here, copy this and make a different method is balanced BP, and here what we would get is, instead of this, we would also get a map of t node and integer. We can call it memo, and while calling this we can call this method. Okay, and we can pass here root and new hash map. Okay, so we are getting a memo here, and okay, so let's see like where is the maximum calculation happening. So in my opinion it's happening here, although it's happening here also, but here is probably the maximum calculation happening. So let's pass this memo here. So we'll pass it here, and before returning we can check if memo dot contains key root. If we have this key, then we would return the height from here also. It's if memo dot get root. Okay, so it would return the height, and before returning we would keep this information here, and instead of returning we can just return this. Okay, it makes sense. And here while calculating this height we would pass memo and memo. Okay, we can apply this here also, like this would further optimize it, but so memoization technique can be applied to is balanced also, like through this dynamic programming. Let's also change this to dp, and here also we are passing this memo and memo. Okay, so okay, because it's also being recursively called, and with this I think we should be able to make it faster, much faster than 94 milliseconds. Let's try to run it. 40. Okay, oh, this is root. Okay, so should be memo, and memo we are putting this. Okay, and while calling this get methods, get height, we should also pass memo. Okay, let's try to submit it. So we have significantly improved this to 3 milliseconds. We can further improve it by applying memoization to is balanced. So try it and give your feedback in the comments. So till then, see you tomorrow, and see you in the next one.